In our previous lesson, we learned on quadrants, positive and negative angles. So we learned that if we have this Cartesian plane of x and y with negative x and also negative y, so now this is the first quadrant, this will be the second quadrant, this is the third quadrant, and this is the fourth quadrant. Also, the Cartesian plane can symbolize the direction of the angle, where this will be the anti-clockwise direction, representing the positive angles. And if you have something in the clockwise direction, this will represent the negative angles. Similarly, the first quadrant, the range of the first quadrant is from 0 degrees to 90 degrees. So we have 0 degrees less than x, less than 90 degrees. For the second quadrant, we have 90 degrees to 180 degrees. So we have 0 degrees, or 90 degrees rather, less than x, less than 180 degrees. And similarly, for the third quadrant, we have the angle in the range of 180 degrees and 270 degrees. So we have 180 degrees less than x, less than 270 degrees. And finally, for the fourth quadrant, we have the range from 270 degrees to 360 degrees. So that will give us from 270 degrees less than or equals to x, less than or equals to 360 degrees. Now, we want to look at related acute angles. Acute angles are angles that are less than 90 degrees. So this is our goal. Whatever angle we have, let's say we have 230 degrees, we understand that it is positive angle and it is starting from the positive x-axis in the anti-clockwise direction to give us 230 degrees. We want to know what will be the related acute angle. Let's call this theta, or maybe x. Okay, or let's take for instance, we have an angle of 165 degrees starting from the positive x-axis. 165 degrees is in the second quadrant because it is greater than 90 but less than 180 degrees. We want to look for the relative acute angle x. So this will be taking a look at in by quadrants. So let's look at the first quadrant now. The first quadrant says we have an angle. Let's call that angle theta. Now angle theta is less than 90. Theta is less than 90. So this is already acute in its nature. So we are not going to do anything in that case. Let's look at the second quadrant. If we have an angle represented in the second quadrant and we call it angle theta, we are looking for the relative acute angle. Should we call it x or should we call it alpha? Let's use x. Now we understand that the total angle from positive x to negative x when it is passing through positive y is from 0 degrees passing through 90 degrees to 180 degrees. Now this is equivalent to us thinking that the sum of angles on a straight line, okay, is 180 degrees. So let's go back here. If the sum of angles here is 180 degrees and this is theta, so let's bring it out. I have theta, and I have x. Therefore, if the sum of angles in the straight line is 180 degrees, so I'm saying that theta plus x is equals to 180 degrees. Then I can have an expression for x, that x is equals to what? 180 degrees minus theta. So we have found the equivalent acute angle, that x is 180 degrees minus theta. Now remember that in the first quadrant, the equivalent acute angle is simply theta, because this is less than x, less than 90. Now in the same vein, we can see now that x here is less than 90 degrees. Let's go ahead and move to the third quadrant. If we move to the third quadrant, that means we have an angle represented in this direction. So you just start from the positive x-axis, and let's call it angle theta. In the same way, this is 0 degrees, this is 90 degrees, and also this is 180 degrees, this is 270 degrees. Now the small relative acute angle that we are looking for is the angle with respect to the x-axis. So this is angle x. Now if you look at this in the second quadrant, it was relative to the x-axis. So we are taking the x-axis as the point of contact. We are taking the x-axis as the point of contact. In the same way here, we are also taking the angle as the point of contact. Now we understand from here now that the sum of angles on the straight line is 180 degrees. And now we have an angle passing through the straight line, and this is x. This is 180 degrees. Okay, and we know that this total angle, let's simplify this further. We have 180 degrees. We have an extra angle called x, and the total angle in this case from positive x-axis is theta. So with that case, we can find an expression for x and say that x, okay, x plus theta, or rather x plus 180 degrees is equals to theta. So therefore x will be equals to theta minus 180 degrees. So we now have an expression for x, that x is theta minus 180 degrees. So this angle here is also less than 90 degrees, which is the related acute angle. Let's move on now to the final quadrant, that's the fourth quadrant. The fourth quadrant is here, so that means we are looking for an angle that is represented here, and we know that this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and likewise 360 degrees. So if we have an angle starting from here in the positive direction, and we call it theta, let's call this angle theta. Now we're looking for the relative acute angle of x. Now remember why we chose this x, because it is with respect to the x-axis. Remember, with respect to the x-axis, with respect to the x-axis, and also with respect to the x-axis. Now if the total angle at a point, as we established in the first lesson video, the sum of angles at a point is 360 degrees, and then we have an angle here that is x degrees. So we can say that, okay, we have theta, theta is represented from here to here in the anti-clockwise direction. So it should be from here to here, theta. So with that, we can say that theta plus x is equals to 360 degrees. Therefore, x will be equals to what? 360 degrees minus theta. So now we have the relative acute angle, which is x is equals to 360 degrees minus theta. Now, all these are important. We are still laying the foundation on how to come about trigonometric ratios of angles from 0 degrees to 360 degrees. Now, let's draw the conclusion line that we have now. If you have the first quadrant, we have the second quadrant, the third quadrant, and likewise the fourth quadrant. The first thing we established was the fact that the first quadrant ranges from 0 degrees to 90 degrees. So we have 0 degrees to 90 degrees. The second quadrant ranges from 90 degrees to 180 degrees. So we have 90 degrees and we also have 180 degrees. Likewise, the third quadrant ranges from 180 degrees to 70 degrees, which is here. And the fourth quadrant ranges from 180 degrees to 70 degrees down to 360 degrees. So we have our 360 degrees represented here. Now let's draw a line. Theta here is the acute angle, so it is simple. We'll just say that the related acute angle here is theta, and we can call this x. And if we have another acute angle represented here in the second quadrant, so we have this, an angle represented in the second quadrant. Let's call this angle theta also. So in this case, we understand that the related acute angle x is equals to 180 degrees minus theta, just as we established in the second quadrant. 180 degrees minus theta. Moving on, we move on to the third quadrant now. We understand that we'll have an angle represented here, and if we call this angle theta, the related acute angle is the one with respect to the positive x-axis. So this is angle x. So we are saying that x here is equals to theta minus 180 degrees. And finally, if we have the one in the fourth quadrant, we have our angle theta. The angle x will be given as 360 degrees minus theta. Now let's take some examples, or let's do that in the next lesson video.